go over some of these. The question was to assign oxidation numbers to the elements in each of the following. The first was an ionic compound. We know it's an ionic compound because it's got a metal and a nonmetal. So we could use Rule 3 and what we know about the ionic compounds to just say that the oxidation number of magnesium is +2 and the oxidation number of chlorine is -1. Or we could use Rule 5 that says chlorine is -1 unless it's with oxygen or fluorine, and then set up the equation that said that magnesium plus 2 times the oxidation number of chlorine is equal to 0. We could also use the rule that group 2 metals in compounds always have an oxidation number of +2. So that one was covered like by mega rules. Okay, so the next compound is carbon tetrachloride. Now we have a rule for chlorine, but we don't have one for carbon. That means we have to do a little math. By Rule 5, chlorine is -1 unless it is paired with oxygen or fluorine. So in this case it is -1. So the oxidation number of carbon plus 4 times -1 has to equal 0 because it's a neutral compound. So we do the math and we find that carbon minus 4 is equal to 0. So if we add 4 to both sides of the equation, we end up with carbon, the oxidation number of carbon being +4. Now the next compound is nitrogen, all by its lonesome. Now there's two of them, but they're the same type of atom. So by Rule 2, nitrogen is in its elemental state and its oxidation number is 0. Okay, now we're getting a little trickier. Here we have the polyatomic ion phosphate. And in this case, by Rule 6, oxygen is -2, but we don't have a rule for phosphorus, so we have to do the math. And because it's a polyatomic ion, the sum of the oxidation numbers has to equal -3. So the oxidation number of phosphorus plus the oxidation, 4 times the oxidation number of oxygen is equal to -3. So you do the math, you find out that P minus 8, or the oxidation number of phosphorus minus 8 is equal to -3. If you add 8 to both sides, you wind up with the oxidation number of phosphorus being equal to +5. All right, next question. We have carbon and carbon dioxide. Once again, we have a rule for oxygen, but we don't have a rule for carbon. So we'll just use the Rule 6 for oxygen, and that says that oxygen is -2 unless it's paired with fluorine. So we set up the equation where the oxidation number of carbon is equal to, or I'm sorry, the oxidation number of carbon plus 2 times the oxidation number of oxygen is equal to 0. It's a neutral compound. So if you do the math, you find out that carbon minus 4 is equal to 0. So adding 4 to both sides, you end up with the oxidation number of carbon is equal to +4 in carbon dioxide. How about for chlorine in dichloroheptaoxide? Well, once again, oxygen is -2. So we set up the math again, only this time there's 2 chlorines, but we can still do the math. 2 times the oxidation number of chlorine plus 4 times -2 is equal to 0. So 2 times the oxidation number of chlorine minus 8 equals 0. Add 8 to both sides. 2 times the oxidation number of chlorine is equal to 8. And if we divide both sides by 2, we find out that each chlorine has an oxidation number of +4. Last one, home stretch. Manganese in the permanganate ion. It's a polyatomic ion, so the sum of the oxidation numbers must equal -1. Oxygen, once again, is -2. There is no rule for magnesium, so we have to do some math. In this case, the oxidation number of manganese plus 4 times the oxidation number of oxygen is equal to -1. So you do the math, you find out that manganese minus 8 is equal to -1. And if you add 8 to both sides, you find out that the oxidation number of manganese is +7. This is so important for this chapter and understanding how to do to figure out oxidation reduction reactions at all. So I really want you to be able to do this. There's lots of examples in the book. If you still don't get it, we can go over it again on Monday. Bye.